Hello friends, welcome back to this online lecture series on earthquake resistant design of structures. As you all know, we have already started the discussion regarding the various earthquake protective systems which are going to help us enhance the performance of building when subjected to lateral loads. And under this category, last time we have started the discussion on dampers, where we saw the definition of dampers, the necessity of installing a damper, the functions of the damper, and the behavior of the building when subjected to lateral loads where the damper is going to be present. So in today's lecture, further we will be discussing the 7 different types of dampers and its function and characteristics according to their material that has been selected for manufacturing of these dampers. Now in the previous lecture, we have seen the different types of dampers and we'll start from there on itself so that the connectivity is there. So as you can see, 7 dampers we have listed. The first damper is known as the hydraulic damper. Second damper is viscous damper. Third damper is viscoelastic damper. Fourth is friction damper. Fifth is tune mass damper. Sixth is yielding damper. And seventh is the magnetic damper. Now, all these dampers, by the name itself, you can make out the main material, the characteristic material that is going to be there in that particular type of damper. For example, if I talk about hydraulic damper, then in case of hydraulic damper, we can say that it is basically going to have some fluid as a characteristic material which is going to help us dampen the seismic energy. Same second case is the viscous damper. So in that case, the presence of some viscous material, for example, silicone is going to be there, which is going to dampen the force that will be transferred due to the seismic waves. Then there is viscoelastic damper. So basically, in that viscoelastic damper, the presence of elastomers or rubber pads are going to be there, which are going to absorb the energy that is going to be transferred from the seismic or the ground shaking. Then the fourth is the friction dampers, where again the use of steel plates is going to be there and the energy is dissipated by the friction that is going to take place within the steel plates. Then tune mass dampers are basically known as the passive dampers or the vibration dampers, which are going to dampen the effect of seismic forces on the building, and that is why they are known as tune mass dampers, right? And lastly, we have the yielding damper. So yielding is a characteristics of metal, right? So basically, the metal is going to play a role as a damper in case of yielding dampers. And lastly, the magnetic dampers, where the presence of magnet will be there, copper disc will be there, and piston will also be there. So let us look at each of these dampers one by one in today's lecture. So first of all, I start with the hydraulic dampers, which are also known as oleodynamic devices, right? So when we talk about the hydraulic dampers, then it can be said that it is used with the objective of permitting slowly developing displacement due to the thermal movements, but limiting the response under dynamic loading. So what is going to happen is that the movement due to the characteristics of hydraulic dampers is such that the movement under the dynamic loading will be restricted, but the movement due to the slow displacement or the thermal displacement that is taking place due to the thermal energy will be allowed, right? Now this system dissipates the energy by forcing a fluid through an orifice. Now what is this fluid? This fluid can be either oil or high molecular weight polymers, right? And when we talk about the orifice, then it basically consists of a piston which is going to force its way to the fluid into the cylinder. Now it can be a single cylinder also, and it can also take place with such that the piston is having allowed the movement in all the 3 possible directions. But there is one specific disadvantage of hydraulic damper, and that is that the maintenance, high amount of maintenance is required in case of hydraulic dampers, and that is why this particular type of damper is not suggested to be used. The figure of hydraulic damper is shown, where you can see that a cylinder is there, piston is there, and at the same time there is going to be the fluid is also going to be present in the form of oil or high molecular polymers that are going to be present within the piston cylinder system. Next is the viscous damper. So as I mentioned again, the presence of some viscous material is going to be there, which is going to help us dissipate the energy that is going to be transferred from the seismic waves. So in viscous damper, the seismic energy is absorbed by the silicon based material which is located between the piston and the cylinder arrangement, right? Now these viscous dampers are used in high rise buildings to a great extent, as a result of which the performance of the high rise buildings in seismic prone areas, that is zone 3, zone 4 and zone 5, can be increased when the use of seismic dampers is going to be done. It can operate about the ambient temperature in the range of 40 to 70 degrees Celsius. That is again a characteristic of viscous dampers which can be kept in mind when the building is to be constructed in zones where temperature is going to be very high. And lastly, the viscous damper reduces the vibration of the building subjected to large amount of lateral forces such as wind and earthquake. So, if there is a doubt that a building will undergo vibration under the effect of lateral loads, then in that case, the installation of viscous dampers will eliminate the possibility of vibration happening in the building. The schematic geometry of viscous damper is shown, where you can see that the piston is shown, the cylinder is shown, and within the piston cylinder arrangement, the viscous fluid in the name of silicon based fluid is also going to be present. So whenever the horizontal force or the horizontal thrust is going to be applied to this particular arrangement, then as a result of that, what is going to happen is that this silicon based material which is going to be present within the piston and the cylinder arrangement, it is going to dampen the force of the dampen the transfer of force from the external to the damper, and as a result of that, the further on movement will be dissipated accordingly, and as a result of that, the overall dissipation in the structure will take place, and due to this, the movement or the motion of the structure will be dampened. Next is the viscoelastic dampers. So as again the name is suggesting, it is going to have the presence of an elastic materials. That is, either it is going to have elastomer or rubber pads or lead plugs, which are going to play a key role in functioning of this particular type of dampers. So that another type of damper is a viscoelastic damper that stretches elastomers in combination with the metal parts. So as you can see, there are two types of the sketch is showing, schematic sketch is showing, right? Light gray material and dark gray material. The light gray material is the presence of steel plates, and dark gray material is nothing but the elastomers. So whenever the force is going to be applied in one particular direction, the resistance is going to be offered in the other direction, and whenever the resistance is going to be offered in other direction, due to the presence of these elastomers, a lot of higher amount of energy is going to be absorbed in this particular elastomers, and as a result of that, the amount of energy transferred to the damper itself will be very less, and it will be transferred to the damper is less. Then the connection of the damper with the other lateral load resistance system, from where on the load path is going to continue, these elements are also going to carry very less amount of lateral force, and due to this less amount of lateral force, the motion of the structure and the displacement of the structure is going to be controlled or within the permissible limit to a very great extent, right? Now, just like in case of viscous dampers we have seen, in case of viscoelastic dampers also there are several parameters based on which the functioning of viscoelastic dampers is dependent, where the first parameter is the presence of ambient temperature, second is the loading frequency, then the amount of energy that is transferred to that particular material, and lastly the location of the damper system is also going to be playing a very important role, right? We need to identify the critical location or the critical load path through which the lateral force is going to be transferred from the top of the building to the ground, and accordingly we need to install a damper in that particular moment resisting frame or lateral load resisting frame, as a result of which the entire frame is going to the dissipation of energy will take place in the entire frame, and thereon the movement of the building will be controlled to a great extent, right? And viscoelastic dampers have been successfully incorporated in a number of buildings as a visible energy dissipating systems to suppress the wind and earthquake effects induced due to the building structures. Next is the friction dampers. So again, as I have said, the friction damper basically is talking about the friction that is taking place in the material. Now, which is the material? Then steel plates is basic material that is associated with friction dampers, but it is not necessary that always this material should be of steel. It can be other than steel also, right? So generally a friction damper device consists of several steel plates which are sliding against each other in opposite direction. These steel plates are connected with each other by means of a shimmer pad, separated by shims of friction pad material, right? So the damper dissipation is going to be taking place due to the friction that is going to take place between the movement of this plate or the sliding of the plates with respect to one another, and as a result of that, the amount of force transferred to the building will be reduced to a great extent. And lastly, it is possible to have material other than steel plates also to form the friction damper. Here in the figure you can see that the schematic sketch and the photograph of friction damper is also shown, where the central plate is shown, and from the center plates four other plates are shown, which form the configuration of the friction dampers, right? So the ideal location or as I have said, for friction damper is also going to be in the bracing. If you are going to provide, if the structure is going to be steel structure where the wind forces are going to govern, right? And if you want to control the vibration and displacement of the steel structure, then in that case, if you are going to install this particular type of friction dampers within the bracing frame, that is the braced frame of the structure, then as a result of that, the amount of forces transferred to the building is going to reduce to a great extent, and the performance of steel structure will be also enhanced. Then tune mass dampers. So as we have discussed earlier, tune mass dampers, also known as vibration absorbers or vibration dampers, is a passive control device that is mounted at a specific location in the structure. And as a result of that, the magnitude of vibration or the amplitude is magnitude of vibration to an accepted level is reached, and as a result of that, the motion of the building is controlled to a great extent. As I have said earlier again, the location of this tune mass damper is also going to be a very important, right? And that is what is going to be happening for base isolation system or for dampers also. That is, you need to identify the critical load path, and in that critical load path, if you can fix your damper or install your damper, then only the performance of the building can be enhanced. If you are placing your damper at such a place where it is not connected to the moment resisting frame or the overall geometry of the building, then in that case the local effect will be there, but the global effect will not be there. And the purpose of these dampers is to enhance the global performance of the building also, right? So it is better to identify the critical location and adjust the location of the dampers accordingly in that critical load path wherever possible, right? The application of tune mass dampers can prevent the discomfort, damage, and outright structural failure also, right? Example of tune mass damper is the Bhuj earthquake. After the Bhuj earthquake, the government hospital that was constructed in Bhuj is having the tune mass damper that is installed in the basement. It is still present there till date. If you happen to visit the Bhuj hospital, right? They are frequently used in power transmission, automobiles, tall buildings, and institutional buildings or public buildings also, where the life of the human is controlled and the damage to property is also one of the key features that has to be kept in mind. Second last is the yielding damper. Now, as the name is suggesting, yielding damper is basically going to talk about the yielding of metals, right? And due to this yielding of metals, the dissipation of energy will take place. That is, the yielding damper or metallic yielding energy dissipation device or passive energy device is manufactured easily from yielded metals or alloy material. As you can see in the figure, two figures are shown. The first figure is shown where the yielding of the metal has not taken place, and in the second figure where the earthquake force is transferred to this material, that is the dampers, and after the force has been transferred and the dissipation of energy has taken place, then the yielding of material or the yielding of metal is shown in the second figure, right? So it dissipates the energy through its plastic deformation, that is yielding of the metallic device, which converts the vibration energy and consequently declines the damage to the primary structural elements. That is, what is going to happen is that the local effect can be controlled to a great extent if yielding dampers are going to be installed, because whenever you talk about the collapse of a building, then the collapse of the building is going to be starting from any primary member only, right? And if the damage of primary member is controlled, then the collapse of the building can be controlled automatically, right? So installation of these yielding dampers are going to help in controlling the damage that is likely to be caused to the primary members. And when that can be done, then as a result of that, the performance of the structure can be enhanced and good amount of dissipation of energy can be taking place. So in the figure that you have in front of you, that is the second figure, there you can see the yielding of top and bottom members are shown, as a result of which you can say that due to this yielding of members or yielding of metal, the dissipation of energy has taken place. And lastly, before we conclude today's lecture, the last type of damper is known as the magnetic damper. So when I talk about the magnetic damper, as you can see, it is basically going to consist of two rocks, two pistons, a copper disc, and a rare earth magnet. That is, what is going to happen is that this type of damper is neither expensive nor dependent on temperature. That is going to be, because in the earlier cases we have seen that it is dependent on the temperature. For example, we talk about viscous damper or the viscoelastic damper. In case of viscous damper, we saw that it is going to act in the range of 40 to 70 degrees. In case of viscoelastic, we saw that it was effective in the case of ambient temperature, right? But when you talk about magnetic damper, then it is said that it is not dependent on the ambient, it is not dependent on the temperature. So as a result of that, wherever the restriction of temperature is there, there in that particular case, the magnetic dampers can be thought as an alternative solution to be used as an earthquake protective system, right? And as I have said, it is going to basically consist of two racks, two pistons, a copper disc, and a rare earth magnet. The magnetic damping is not strength, that is why it is effective in dynamic vibration absorbers, which requires less damping, right? So the function of this particular magnetic dampers is such that it is going to help us in absorbing the energy that is going to be released, and after the energy is absorbed, the remaining energy will be transferred to the structure. Whenever this energy will be transferred to the structure, then from there on the members will be carrying on the load, and then it will be transferred to the foundation. But since initially the energy has been absorbed, so as a result of that, what is going to happen is that the amount of force transferred to the structure or the moment resisting frame is going to be very less, and as a result of that, the motion of the structure is going to be dampened, right? So these are all 7 different types of dampers that we have discussed today, wherein the prima facie function of each and every damper is to absorb or dissipate the energy and dampen the motion of the structure, and thus controlling the lateral deflection of the structure to a great extent. I hope this lecture has given you a clear picture about the function of the dampers and the difference between the different types of dampers and the conditions in which they can be used to be installed. Thanks for this particular lecture. Stay tuned for the further lecture series. Thank you.